So the last topic in rational expressions is going to be to plug in the arithmetic that we know how to do with fractions and use the same techniques to apply to rational expressions. So what I want to do is give you an overview of what that would look like. I'm going to do just two examples. One example where we multiply a pair of fractions, and another example where we subtract a pair of fractions. We'll talk about those two examples together, and then I'll give you a couple of problems from this packet to work on your own with your small groups. So first, let's take a look at multiplication. As with any factoring problem, the first step is going to be to identify all the factors. Sorry, rational expression problem. Identify all the factors first. And since we've spent all of our class time today talking about that, I'm going to abbreviate this part of the conversation. The idea being that I'm multiplying these two fractions, and so I have two different numerators to worry about, two different denominators to worry about. Let's find out all the factors of them both. For x squared minus 4x in purple, we can factor that as x times the quantity x minus 4. X squared minus 4 factors as x plus 2, x minus 2. The orange numerator, x squared minus 4x plus 4, factors as x minus 2 times x minus 2. And the red denominator here is kind of a weird one. What you actually want to do anytime the leading coefficient is negative, as it is here, x squared has a negative coefficient in front of it, is factor that negative coefficient out first. Treat that like a GCF. So that then what you end up with is x squared plus x minus 20 to factor, which factors as x plus 5, x minus 4. So step one, factor everything on the table, because ultimately when it comes time to simplify this product, we're going to need to know what all those factors are so that we can divide by them and get rid of them and simplify our answer into its lowest terms. So I always recommend factoring first. Now, after we've done that, it comes time to multiply. And how do you multiply two fractions? Yeah, fractions, when we multiply them, it's the simplest thing we can do arithmetic-wise for fractions. We just multiply straight across the numerator and straight across the denominator. It would be just as though I took this multiplication sign away and I just connected this fraction bar and made it into one gigantic fraction. Right? Multiply all the factors across the numerator, multiply all the factors across the denominator. And now we have a single fraction. And our task is to simplify this single fraction, get it into its lowest terms. And all of the work that we put in ahead of time to figure out what the factors of each of the numerators and denominators were, that work is going to pay off now. Because we have an expression that we can simplify merely by identifying the common factors. What's one example of a pair of common factors here? X minus 4. Yeah, x minus 4 is common to the numerator and denominator. So we know that we're going to be able to divide by it and get rid of it. Are there more? X minus 2 is also an example of a factor in the numerator and denominator that's common. So I can cancel both of those pairs and then just write what I have left. Upstairs, x and x minus 2 survive. Downstairs, this negative 1 survives, and so does this x plus 2 and this x plus 5. So at this point, we're done with all of our arithmetic, and the optional last step would be to just multiply these back out. X times x minus 2 upstairs, x plus 2 times x plus 5 times that negative sign downstairs. That's an optional last step if you want to go there. So keep the strategy here very clear in your mind. The first thing we did is identify all the factors that we could find. That made our job later on down the line simpler. But then it was at this second step where the all-important memory that we have about how to multiply fractions comes in and saves the day, because it tells us we can multiply just as though these were fractions by multiplying straight across the numerator and straight across the denominator. And then having identified all the factors that we need, we just simplify by canceling those factors which are in common. What if this question, instead of asking us to multiply, what if this question had asked us to divide these two rational expressions? Let me change the game here for just a moment. Suppose I put a division sign right there. What would we do differently if we were dividing instead of multiplying? Just like with numbers, rational number fractions, division is the same thing as multiplication by the reciprocal. So that old keep, change, flip strategy that we use for division of fractions applies to division of rational expressions as well. So we would keep the first fraction exactly the same, x times x minus 4 on top, x plus 2 times x minus 2 on the bottom. We would change the division sign for a multiplication sign instead. So that's the change in the keep, change, flip. And then the divisor fraction we would flip upside down into its reciprocal. so that my -1, my x plus 5, and x minus 4 would now be upstairs in the numerator, and my pair of x minus 2's would be downstairs in the denominator. Right? And so when all of that dust settles, we would end up in this example with, clear, so we're just going to trade spaces between those factors. -1, x plus 5, x minus 4, x minus 2, x minus 2. And now, when I try to look across at the common factors, what do I find? What common factors exist in the numerator and denominator now? I don't see any. And so the end game for this division problem would be that at this point we actually can't do any more simplifying. And this awful looking thing is a factorization of our final answer. And if you really, really wanted to invest the time to multiply out all 4 of these binomials and all 3 of these binomials up here, you could. But I'm not going to waste our time with that last optional step. The important part about the division here is that the strategy for dividing 2 rational expressions is just the same as it was when we were dividing fractions. Keep, change, flip. First fraction remains the same. Division changes to multiplication. And the divisor fraction, rational expression, gets replaced by its reciprocal. Trade places with the numerator and the denominator. And then it becomes a multiplication problem, which means multiply straight across the numerator and straight across the denominator.